30 million suns, compressed into a region of space smaller than our solar system, lurking at the heart of a spiral galaxy 135 million light-years from where you're sitting right now. And then, without warning, it erupts. In a matter of hours, this supermassive black hole unleashed winds tearing through space at 60,000 kilometers per second. That's 1/5 the speed of light. That's 134 million miles per hour. And that's faster than anything we've ever watched a black hole produce in real time. But here's the truly bizarre part. The mechanism behind it? It looks almost exactly like something our own sun does every single day. So, here's what happened. In December 2025, the European Space Agency published a remarkable study. An international research team had been pointing two of the world's most powerful X-ray space telescopes at a galaxy called NGC 3783. And they caught something no one had ever seen before. A supermassive black hole right in the act of generating ultra-fast winds. Not over weeks, not over months, in hours, in essentially a single day. And to understand why that's such a big deal, we need to talk about what NGC 3783 actually is, and what's been hiding at its center. This is a barred spiral galaxy. It's about 135 million light-years away, sitting in the constellation Centaurus, which, for those of you in the Northern Hemisphere, means you'd need to travel south to see it. It was first cataloged back in 1835, and it's absolutely gorgeous. But beauty isn't what makes this galaxy famous. What makes it famous is that incredibly bright center. And that's because NGC 3783 is what astronomers call a Seyfert galaxy, specifically a Type 1 Seyfert. And that means something very particular is going on at its core. It has what's called an active galactic nucleus, an AGN. And that's essentially a polite way of saying there's a supermassive black hole at the center of this galaxy, and it is actively pulling in enormous amounts of material from its surroundings. So let's take a moment here, because the phrase supermassive black hole gets thrown around a lot. But the one inside NGC 3783 has a mass of approximately 30 million suns. Just think about that for a second. 30 million suns, compressed into a region of space smaller than our solar system. And this thing is relentlessly active. Its gravitational pull is drawing in gas, dust, and stellar material from the surrounding environment. But here's what a lot of people don't realize. Not everything that falls toward a black hole actually makes it in. In fact, a surprising amount of material gets redirected, superheated, and in some cases violently expelled back out. What happens is that the incoming material forms a swirling, superheated disk around the black hole. This is the accretion disk. Think of it kind of like water spiraling down a drain, except this water is a plasma heated to millions of degrees, and the drain is a gravitational abyss that warps the fabric of space and time. And as this material spirals inward, friction and gravitational forces heat it up so intensely that it blazes across the entire electromagnetic spectrum. X-rays, ultraviolet, visible light, infrared, radio, everything. That's what makes the center of NGC 3783 so incredibly luminous. It's so bright, in fact, that when the Hubble Space Telescope photographed this galaxy, the core produced diffraction spikes, something you normally only see around individual stars. But the accretion disk isn't the whole story. Surrounding it, there's a thick donut-shaped structure of cooler dust called the torus. And threading through all of this is an enormously powerful magnetic field. And this is where things get really interesting. Because that magnetic field, it doesn't just sit there quietly. It's tangled, it's dynamic, it's under incredible stress. And sometimes, it snaps. So here's where the discovery begins. The research team was simultaneously using two space telescopes to study the black hole in NGC 3783. The first was XMM-Newton, the European Space Agency's veteran X-ray observatory. This thing has been in space for over 25 years. It's a workhorse. The second was XRISM. That's the X-ray imaging and spectroscopy mission, which is much newer, launched by the Japanese Space Agency, JAXA, with ESA and NASA participation in September 2023. And these two telescopes have very different strengths. XMM-Newton is great at tracking how things change over time. It watched the flare with its optical monitor and measured how far the wind spread using its European photon imaging camera. XRISM, on the other hand, carries an instrument called Resolve, which is incredibly precise at measuring the speed and chemical fingerprint of cosmic gases. It's like having one telescope that's a great cinematographer and another that's a forensic scientist. And together, they caught something extraordinary. First, they observed a sudden bright X-ray flare erupt from the region around the black hole. This wasn't a slow brightening. It was a sharp burst, a brief, intense flash of X-ray radiation. The material close to the event horizon had, it seems, become superheated and violently energized in a very short time. And then the flare began to fade. But as it faded, something new appeared. XRISM's Resolve instrument picked up the unmistakable signatures of a powerful wind. Material blasting outward from the vicinity of the black hole at 60,000 kilometers per second. That is 20% of the speed of light. And the most remarkable thing? The entire sequence, flared a full-blown, ultra-fast wind, unfolded in less than a day. No one had ever watched a black hole generate winds this quickly before. Okay, so now we get to the part of this story that I think is the most fascinating. Because the question isn't just what happened, the question is how. How did this black hole create winds so incredibly fast? And the answer seems to be the same way the sun does it. Our sun has an extremely active magnetic field. It's constantly in motion, twisting, tangling, building up tension. And sometimes those magnetic field lines get so twisted and strained that they snap and reconnect in a violent process called magnetic reconnection. When that happens, you get a solar flare, a sudden burst of radiation from the sun's surface. But that's often not the end of it, because that same reconnection event frequently flings a massive glob of plasma, electrically charged gas, out into space. This is a coronal mass ejection, a CME. And when one of these hits Earth, it can trigger beautiful aurora displays, but also disrupt satellites and power grids. 1,500 kilometers per second. That's roughly 3.4 million miles per hour. Sounds fast, right? Now compare that to the black hole. Its winds were clocked at 60,000 kilometers per second. That's 40 times faster than a powerful solar eruption. And that's because the black hole at the center of NGC 3783 is 30 million times the mass of the Sun. And the magnetic fields around it are millions of times stronger. But the physics, the underlying mechanism, appears to be the same. The tangled magnetic field around the black hole suddenly untwisted, releasing stored energy in a violent burst. Just like a solar flare. Just like a coronal mass ejection. And this is what makes this discovery so striking. The winds seem to have formed through exactly the same kind of magnetic process that drives eruptions on our own star, but on a scale that's almost impossible to visualize. The researchers describe the resemblance to solar physics as something that makes supermassive black holes seem a little less alien. And I think that's a genuinely beautiful finding, because it tells us something profound about the universe. The same fundamental physics that governs our little star also governs the most extreme objects in the cosmos. Black holes, for all their mystery, sometimes behave in surprisingly familiar ways. Now, some of you might be thinking, wait, don't black holes already shoot stuff out at near light speed? What about those giant jets? And you'd be absolutely right to ask that. Supermassive black holes that are actively accreting material are well known for producing what are called relativistic jets. incredibly narrow, incredibly powerful streams of plasma that blast out from the magnetic poles of the black hole. Some of these jets can stretch over more than 1,000,000 light-years, wider than the arms of their host galaxies. And they can reach speeds much closer to the speed of light than what we're talking about here. But those jets are different from what was observed in NGC 3783. Jets are continuous, long-lived, tightly collimated structures. They're like cosmic blowtorches. What the research team observed was more like a sudden detonation, a one-off burst of wind, broader in its spread, triggered by a specific flare event and forming on an absurdly fast timescale. And understanding these winds specifically matters, because it turns out they might be even more important for the fate of galaxies than the jets are. Here's the thing about supermassive black holes that doesn't get enough attention. They're not just passive gravitational anchors sitting at the centers of galaxies. They're active participants in how their entire galaxy evolves. And the mechanism for that is called AGN feedback. The idea goes like this. When a supermassive black hole is actively accreting material, it's producing enormous amounts of energy, through radiation, through jets, and through winds, like the one we've been discussing. And that energy doesn't stay local. It pushes outward into the surrounding galaxy. And this creates a complicated feedback loop. On one hand, these powerful outflows can sweep gas and dust right out of the galaxy, depriving it of the raw material it needs to form new stars. That's negative feedback. The black hole is essentially clearing its own surroundings and starving the galaxy of new stellar generations. But on the other hand, and this is the counterintuitive part, these same winds can also compress clouds of gas as they pass through them. And when you compress a gas cloud enough, it collapses. And when it collapses, new stars are born. That's positive feedback. The black hole is inadvertently triggering the birth of new stars, even as it threatens to suppress them overall. So which one wins? Well, it depends. It depends on the power of the winds, the density of the surrounding gas, the geometry of the galaxy, and probably a dozen other variables that cosmological simulations are still trying to sort out. But the bottom line is this. Supermassive black holes, through their winds and jets, are one of the primary sculptors of galaxy evolution in the universe. Without AGN feedback, our models of the cosmos simply don't work. Galaxies would be far too massive, far too bright, and far too uniform. The universe would look completely different. So let's step back for a moment. What did we actually learn from this one observation? We learned that a supermassive black hole can generate ultra-fast winds in less than a day, something no one had directly witnessed before. We learned that the mechanism behind it looks remarkably like the magnetic reconnection process that drives solar flares and coronal mass ejections from our own star. And we learned that the same fundamental physics operates across scales that are, quite frankly, difficult for the human brain to comprehend. And I think there's something quietly reassuring about that. The universe is vast and strange and often terrifying in its extremes. But it's also consistent. There's an order to the madness. This discovery was only possible because two telescopes from different agencies, different countries, different decades of engineering happened to be looking at the same black hole at the same time. XMM-Newton, a veteran with 25 years of service. XRISM, the newcomer, barely 2 years into its mission. Together, they caught a moment that might last only hours in the lifetime of a galaxy. And the story isn't over. The team plans to use this same collaborative approach to study other flaring AGNs, to see if this kind of rapid wind formation is a common phenomenon or a rare cosmic event. Either answer would be fascinating. If it's common, it means AGN feedback is even more dynamic and responsive than we thought. Black holes constantly erupting with winds that reshape their galaxies in real time. If it's rare, it means we were extraordinarily lucky to catch it, and it raises the question, what else are we missing in the brief moments we're not watching? Either way, the next time you see footage of a solar flare erupting from the surface of our sun, just remember, somewhere out there, a black hole 30 million times more massive is doing the exact same thing, just a little harder. If you enjoyed this, consider sharing it with someone who'd love to know that black holes have something in common with our star.